Well, more specifically about the research, because you were
Right.
recently telling me about a project you're working on in quantum metrology, right?
Right.
Can you maybe explain that a
Sure.
bit? Because you were beginning to get some data from that.
Right.
If you can share that.
Right. Yeah, this is actually part of a long-term research. That I would say started with my PhD thesis. In my PhD thesis, I was looking at the dynamics
Just a few years ago.
a few years ago. Yeah, I'm a young guy, you know.
Yeah.
So there I studied the dynamics of an excited atom,
Okay.
which is decay and releasing photons in the environment. How does that change with time? How do you describe the dynamics of that process? And that was an example of a quantum system interacting with the environment. And I think that followed me through my career as a physicist. I have been very interested in understanding the dynamics of quantum systems interacting with the environment. There are several reasons for that. One of them is that the environment is always there. So systems that do not interact with the environment, they do not exist. Of course, you can approximate with very low temperatures. You can approximate this system interacting with the environment as a pure system, but you know it's an approximation. So mostly we have systems interacting with the environment. So I focus on that. So that was one of the reasons. That's the real thing. But the other reason is more subtle. Is the understanding how the classical world shows up with this quantum ingredient on the basis of it. How can the classical world emerge from quantum physics? Which I think is a very basic problem. And now we know that a big part of this question is answered if you consider the role of the environment. The environment transforms quantum systems into classical systems.